can you go to Moodle and open up last year's physics exam end semester version 1? Anyways, when I did give you help, like in the coursework too, you know, for the lab report, you didn't even come to all these assessment supports. You like showed up like an hour late for some of them. So you're just never happy.
You are going to have same time with intake 2 students, right?
Intake 2? Same time for what?
For coursework 2.
Maybe not. I don't know. Possibly not. We'll have to see how our semester 2 goes. Okay, what am I opening? Internet. Right, do you have the exam open there, Andrew?
Yeah. Which one do you open?
We'll do version 1 if there's a version 1.
Yeah. 20.
Whatever the most recent one is for end of semester 2. 15, 16 version 1, can you open? Can I have a look and I'll tell you which one to do now. So, do you have this exam open?
Yeah.
Let's see. No. Oh, I like number 2. Kurt Chop. But what I want you to do right now is B3. Oh, I like B4 as well. B3.
Okay.
If this was your exam, you definitely should do B3 for 2 reasons. Number 1, it's about atoms, and number 2, it's the graph question. The graph question, I mean, is the question where you have to make a graph. Combined together, graph atom question, it's the easiest combination. So what's that? B3. Can you try B3? And I'll do it now. It's okay, Sean. You're not in a speaking exam now. You don't have to. Pretty nice question, isn't it?
Mm-hmm.
Pretty good.
This is supposedly to be a straight line.
Supposed to be.
Okay.
What did you get?
No, it's a bar like graph. It's not a straight line.
Finished? Which part are you on, Monica?
Teacher, when we are doing graph question, we have to use graph to answer all the questions, like outline, activity after 20 minutes.
Well, if you require constants that come from the graph, you have to use those. But when it says determine the activity, I don't think they actually mean to read it from the graph. I mean, I don't think they mean that. The reason is because of the verb determine. If they said something like estimate, use the graph then. Is this okay, Chu? You look confused. You look unhappy. Is it because of your speaking exam? No.
Sure.
Yeah.
What is the radioactive decay formula?
Lambda. It's the lambda.
I mean the e to the power of 1.
Oh, the equation?
Yeah.
For which activity?
Yeah. The initial and
The activity equals A0 E minus lambda t. Power minus lambda t. No? Finished?
How do I find decay constant from the graph?
Maybe it's time for me to do this one now.
Yeah.
Okay. A part 1. Sean's going to tell me this.
we have same questions but different solutions.
No. Nucleon number.
Oh.
What's the nucleon number? You can do this, Sean. We believe in you. Don't help Sean now. Easy. Okay, Jerry, what is it? I don't give me a full sentence. A full sentence.
The number of the sum of the
Oh, wonderful! Oh, wonderful! I love it. The sum of
number of photon
Oh, that's why you're going to get an A in your speaking exam. Right. A plus, yeah. Very good, very good, very good. Okay. Francium 221 contains 134 neutrons and decays by releasing an alpha to become acetane. Right, so write down the equation. Right, so FR 221.
Yes. 87.
87, thank you, thank you. That becomes acetane, is it?
Yes.
Now, because there's an alpha, this one has to be 85. Yeah? And this is 217.
Should really contain energy.
Yeah, do they want us to write that down?
Even if they didn't.
Yeah, even if they didn't, I'm not going to take marks away for writing it down. You could write down a bit of energy here. It's interesting actually, in the marking scheme I don't think they usually care. What's wrong, Sean?
Why is 85?
Oh, is it not 80y? 221 minus 134.
Oh.
Yeah.
85. It's 87.
Yeah,
I said why it's 85? Because
Oh, this one?
Yes.
Well, because, you know, 85 and 2 make 87. 217 and 4 is 221. Needs to balance. What's wrong, Sean?
Oh, yeah.
Nucleon number, yeah.
Is it a very good math?
It's a mass number, yeah. Continue?
Yes.
Are you sure, Sean?
Yes.
Because, Sean, you really need to get the full marks here. This, Sean, it's a good 2 marks. Okay. Now, copy and complete the table. Alright, so I just need to log this. Yeah, easy peasy. Boom. Not cheating much. Right. Okay? 2 marks, easy 2 marks. Make the graph. Alright. So in the exam, just open up Excel, highlight this. Okay. Yeah, you guys have to use graph paper, that sucks. Okay. Right, what's the title? It's a log of activity against time. And the x is time in minutes, and the y is log activity, which is in mega equals becquerels. Okay. Right, and that's what the graph should be. And of course you need to include the straight lines. Will I show the equation? I will. What's wrong? What's happened? Oh. Right, how many marks is that now? 4 marks.
All four.
Use the graph to calculate the decay constant.
Well,
Yeah.
what should we contain in our graph?
Your graph, I want to see the X title, the Y label, the X label, a title.
A title. Title.
Yes, of course, a title. Somebody could look at that and think it's a ham sandwich unless you put a title on top. You need to put the points on it, like dots, and a straight line.
The title can we use symbol, like,
Yes.
No equation.
No, I don't need the equation.
喺度冇啊？喺度 is log.
I just wrote log of activity against time. Continue? So, how do you get the lambda? Yeah, I think it's, what part am I on now? B part 3, isn't it?
Yeah.
So the decay constant is equal to minus the slope, the gradient, which is basically the y over the x here, with the minus. So if I look at my graph, if I take this point, it's 2.5 down to, what's that, 0.75? So it's like 2.5 minus 0.75 over 12. Yeah, well, I've knocked out both minuses because I know my lambda is a positive. So what's that now? That's 0.25, 1.75 over 12, is it?
0.1.
Yeah, what can you get, please, on the calculator? What? Well, what did I get in my one?
0.15.
In my one? Yeah?
0.142.
146.
Right,
One
stop.
Okay.
2.
Okay.
I just want you to tell me what my one is.
146.
0.146.
Yeah.
That's my one here. I know, but I'm trying to show you in the exam, you would have to read off the points. Now, Excel can calculate it perfectly. So the perfect answer is here, 0.144. Now I got 0.146. So my error is only 0.002. Not bad. Not bad at all. For somebody just reading it from the screen. Because I have to kind of estimate it here. It's quite good. So I'm going to actually use 0.144 because that's what I have on Excel.
Oh.
Simple.
Yeah.
But can we use A equals A0 equals minus lambda t?
1 second, yeah, I'll answer that. I actually just forgot to write in the units here. I should put in the units. Now, to be careful with what the units are. Lambda equals 0.144. Now, the units for a lambda, it is, no, you're thinking of wavelength. It's per seconds. Well, it's not per seconds here. Yeah, but it's not that here. It's per minutes. Because the time unit is minutes. Okay. Now, you're asking me what, KJ, can we use?
A0 equals minus lambda t.
No. Why not? Because the question says use the graph.
But if you use it, I get different answer.
I know. What answers you get?
0.00948.
Yeah, but are you using seconds or minutes?
Minutes.
And what are you using as A0?
2.51.
But A0 is 12.31.
But the graph is LNA.
Hang on. You can't have it both ways. You can't use the graph and use the formula. So which are we using? The graph or the formula? Which? Formula, okay. So, in the formula, what's A0? The initial activity. Now, according to the data, what is the initial activity? Yeah.
But if we...
How could there be a but? What's the but? What?
If we let it with a natural
But why?
integrate.
No, stop! KJ, stop! Why would you use natural log? The formula's for A0, isn't it?
Yeah.
Yeah, is the formula for log A0? Is it? Is it? Is it log A0 or A0?
Just A0.
Yes. No, you can't. How could there be a but? It's like if I said E equals MC squared, and then I said, yeah, but can't I use log M?
No, but to get rid of E.
Okay, fine. Now, see, that's different. So you want to use this formula, but get rid of E.
Yeah.
Fine. So we use log. Okay. So I get log A equals log A0, yes, plus log E minus lambda t. So I get log A equals log A0 minus lambda t. Yes? So I get log A equals minus lambda t plus log A0. Right. Okay. So now what? What did you do next?
Bring ln A0 to
You're
left.
making a formula for lambda.
Yeah.
Okay, grand. So you get lambda equals log A0 minus log A over t.
Yep.
Isn't it A minus A0?
I think this is right because I took that to the left and that to the right.
Yeah, correct.
So that's log A0 over A over t. Yeah. So what did you use for A0 and A and t?
A0 for 2.51 and A.
Wait, hang on. A0 is what?
2.51.
So if you put 2.51 in here, you're doing log of 2.51.
Then it will be double.
So you're like log.
Okay.
So you can put 2.51 here.
Okay.
Is that what you did, or did you put it here?
Okay.
Yeah. So you can do it your way, or you can do it the way I taught you. You must remember your teacher is lazy, and he will find the easiest way that's most likely to get the right answer.
We will get the same answer.
Eventually you will.
Each way.
No, stop! Lee!
Yeah.
Lee!
Yeah.
Look at me, stop pressing buttons. I don't want you doing it this way, I want you doing it the way you're supposed to do it.
I know.
Lee, if you continue pressing buttons now, I'll take your phone and calculator off you.
The last time, let me debug.
No! You press another button there, and I'll come down to you.
You have to know it.
No, you don't.
It's kind of progressing process of learning.
No, but the question.
It's not a process of learning, it's a process of annoying your teacher.
Also, you get different answer.
Did you?
I didn't press it. I mean, I didn't divide by 2, but I can do it in my
You
brain.
see, what you're doing now is annoying me. That's all that's being accomplished right now. You think you're learning or doing something smart. Instead, you're just annoying me. Right, let's have a look. Which one do you want me to use? The first or the second here? This one?
Yeah.
Yeah?
Isn't it the same?
Yeah, it's the flippin' same thing as what I just did right here. Okay, this is log, this is a log, and this is the time. 2.5? Wasn't that log A0? Yeah. 0.75, that's the A at the end? The log A at the end?
Isn't it 0.81?
Oh, well, excuse me, it's close enough. 0.75, 0.81, whatever.
That's huge difference.
Well, I said 0.75 and I was looking at the graph. Like,
It's kind of the same.
yeah, but even if it's a small difference, it shouldn't make a huge effect on the answer. Like, I'm looking here. This looks more, I said 0.75. If you want to say 0.81, that's fine. So let's see what you get then. So you have 2.5 minus 0.81, you said, over 12. So 0.1408. So big flippin' poopin' deal. Alright. Are we finished? Are we finished annoying me? Can I continue? Right. What's the half-life? Fine. Half-life, we have the formula for that. What's the... half-life is log 2 over the lambda. Okay, now please just type this in, my one, log 2 over 0.144.
4.814.
Now is that my one?
Mm-hmm. Yeah.
4.814 minutes. Okay. Do you know why it's minutes, Jerry? What's the activity after 20 minutes? Okay, now we have to use our formula. A equals A0 E minus lambda T. What's the A0? It's something like 12.31 mega.
Yeah. Do you need to use mega?
Oh yeah.
Can't our answer just be mega?
Yeah.
It's the same, right?
Yes. E minus lambda T. 0.69 mega BQ. Alright. Next one, part 6. What's the... Oh, this is the end. What's the initial number of atoms? So what's the end 0? Alright, so you have the formula A0 equals minus lambda N0.
Yeah.
So that means A0 equals minus... N0 equals minus A0 over lambda. What was my activity? 12.31, wasn't it? Mega. So the answer is 85.5. Wait a second. 85.5
Mega.
times 10 to the 6 atoms. Yes, Monica.
Do you have to change the lambda to the second?
You don't have to, as long as you're mindful for the rest of the question that your time unit is minute.
No.
Oh, thank you, Monica, thank you. Yeah, I screwed up here.
Oops.
I screwed up, I know. Monica spotted, thank you. In this formula here, the activity... Well, the activity here... Flippity flip.
Per second.
I know that. No, I know, but I don't have to go that far back, sorry. Yeah. Thank you, Monica. This is fine. This is now bad. I made a very big mistake here. My mistake was, here I was using minutes, whereas here I'm actually forgot I'm using seconds. Because if you look here, it's in the unit of BQ. And BQ is per second. So what's the easiest thing to do? I think the easiest thing to do would be to change this into per minutes, rather than to change this into seconds.
No, I prefer change.
You prefer the other way? Okay, fine.
How do we change BQ to second, by the way?
Well, actually, that doesn't...
Divided by 6.
Well, hold on now, but actually, I don't think that affects this answer. No, it doesn't affect this answer. Oh, it only affects the last answer then. How do I redo? Bump, redo. Bump. That's not as cool. Alright, sorry, that is correct. It's the last one I need to change, thank you.
Why?
Because I can't mix it here. A0 equals minus lambda N0. So, N0 equals minus A0 over lambda. And the A0 is 12.31 times 10 to the 6th. And the lambda is 0.144 minutes. Yeah, so I just need to fix my answer by dividing by 60. And I get 1.42. What? You just told me to divide by 60.
Joe, why is the last one fine?
Why is this one fine?
Yeah.
Oh, well, because I know that if I change this into seconds and this into seconds, and then put it in fact, this will be the same number.
Oh.
The reason is actually, yeah, if you look here, lambda times t. What unit is t?
Minute.
Minutes. And what unit is lambda?
Minute.
Per minute. So what unit is lambda t?
0.
No unit, meaning it's of no consequence what unit I use. What? Don't tell me I just typed this in wrong. Okay, fine. See? Right. 12.31 times 10 to the power of 6. 0.144 times 60. Yeah.
No, it's divided by 4.
No. It's zero. Oh, yes. It's 0.144 per minute. Yeah, sorry. Thank you, Monica. It's like this instead of multiply. Yeah? 5129 mega?
So big?
Yeah. Five, 1, 2, 9. Alright. Flip, flip, flip. See, I thought by keeping it into minutes I would save time. But if you get it wrong because you didn't convert into seconds, maybe it's not worth it. Did the question say to use minutes in the answer, or seconds, or doesn't care? Okay. Yes. Yes. Well, consider the worst case. If we made a mistake in the end, well, 3 marks would be the worst case, but you wouldn't lose all 3 marks. So you would lose maybe 2 marks, maybe even just 1 mark. So you could easily get 18 out of 20, 90%. If all my students got 90%, I'd be very happy.
Oh, is that possible?
Is it possible? Yeah, if I only had one student who was really good, then all my students could get 90.
Who?
Oh, you want me to pick one person from this class?
No.
I don't know if there's any 90%ers in the class.
But
I see 80%ers, you know, and like 70%ers. You don't get 90%ers so often.
we have coursework, I mean.
No, I'm talking about the exam.
Oh.
How many usually?
0.
Really? Whoa.
Well, 90 is hard.
0 to 1. Depends on the year. The highest ever is 98.
That's the battery guy.
Huh?
Battery guy.
Yeah. Yeah. Battery guy.
Who's the battery guy?
He got 98. The only reason he didn't get 100 is the diagram had two cells on it, and each cell was like 3 volts, but he only used 3 instead of 6, because the diagram was actually two trees instead of a single tree.
Andrew as well,
Huh?
You just want to kill your name,
right?
isn't it?
Yeah.
What?
Andrew as well, right?
What about Andrew?
I mean the previous. Andrew.
Oh, from last year, the award winner. I don't think he was a 90%er. 90% is hard.
Yeah. You can make sugar mistake.
I mean, you should lose 10% by just making silly mistakes like what I just did. Okay? So then, the student would not have as much knowledge as me in the exam. So you can immediately lose another 10% because the question is something that they can't do. So like, the most you can hope for is 80% as a student. Because you lose 10 automatically for silly mistakes, and another 10 for seeing something you don't understand.
And plus the work done.
Yeah. Yeah, you know, because the reality is you're a human, not a machine. So people do some silly mistakes in the exam. Like, I've seen some things where I'm like, what the fudge did they do that for? And you think, no, I won't do that. And then you'll do the exam, you'll do something silly, like you put time on the y-axis and activity on the x-axis. or something crazy like that. And you're thinking now in the class, no, I won't do that, that's silly. But you know, when you're hot and it's sweaty and it's smelly and you stayed up all night preparing for the exam and you haven't showered in days, and, you know. Andrew. Maybe if you didn't spend so much time on your hair. Yeah, you know. All right. I think the atom question is quite good. Actually, this actually gives me a good chance now to give you a guideline on what questions to choose in the exam. Okay. So I'll make a little tray. Why does this not disappear anymore? It's annoying me. Okay, so the first thing, you have to choose 3 questions. Jerry!
Yeah.
I'm giving you some extremely important and useful exam advice.
Yeah.
Listen carefully. So when you look at section B, this is the first question is there an atom question? If the answer is yes, you do it.
Yeah.
Okay? Sometimes you will be very lucky and you can ask yourself this question: is there another atom question? If there is, you do that one too. Students perform best on the atom question. Students can easily get somewhere between 17 out of 20 and 20 out of 20 for the atoms question.
Yeah.
Okay, so it's the best question. Right. Next one. Is there a graph question?
What is that atom question?
Look, alright. There won't be. I'd be shocked.
Wait, how many questions?
Alright, hang on. Just please, right? I'll do it like this, like a tray, okay? The first question you should do, if there is one, is the atom question, okay? If you're very lucky and it's Christmas and it's your birthday wrapped in one, you'll get a second atom question which you can do. If you're lucky.
Yeah.
Okay, the third thing you should do.
Third one.
What happened? It's a graph question.
Oh.
Now sometimes though the graph question is the atoms question, so you know, in the worst case is there's only one atom question and it's also the graph question. Like this year. I mean, this is a nice thing, but the bad news is it means the graph question, which is usually easy, is also the atom question, which is usually easy. So both easy questions have made one easy question. So you've actually have no choices here. So then what do we do after this? Well, I like the wave question.
Yeah.
And the reason I like the wave question is it's very, very limited possibilities. Like there's really only 2 types of wave questions. The 2 types are the double slit and the stationary wave. You know, the standing wave, like in the microwave or the sound wave. Okay? So, you know, it's very easy to prepare because there's only 2 possibilities really. So I like this as 4th priority. 5th one, I do like the materials question. And the reason I like it is because often it just uses PV equals nRT. It's quite similar to your chemistry. I like Kirchhoff, but I don't think students like it. So the 6th one is the electricity.
What about mechanics?
Now, the mechanics is kind of interesting because the mechanics, it really depends on what type of mechanics it is. Okay, so you can have a simple mechanics, like something like just a simple UVATS, or even a projectile. You know, it'd be pretty simple. So if you get, or conservation of momentum. Yeah, so if you get a simple mechanics question, you might want to consider that kind of like somewhere here on your list. But a hard mechanics question, like, you know, I think the hardest one I've seen is when you have something being projected down a hill.
Oh.
Yeah, I would consider that to be below electricity. Yeah, well, no, actually, down the bottom here.
Field. Last four.
Let's try our theory and see what happens with this paper. So, let's see if there's atoms. Atoms, no. No. Yes. So we would do B3. Okay. Is there another atoms question? No. There's not. Okay, so we can't do that. Now we do the graph question. The graph question this year is also the atom question. This is kind of bad news because it means we still have only one choice, B3. Okay, well, is there a wave question? Let's see. I think there is.
Easy mechanics.
Yeah, this is a simple Snell's law.
Yeah.
It's nice and simple. And this one here is our double slit. And the last one here is also a double slit. Okay, so that's good. B5. Alright, is there materials one? Okay, so is there materials one? There is not a materials one, so that's kind of bad. Is there electricity one? There is.
This one. Oh.
Yeah, no, I like it. I like it. B2, I do like it. Now the question is mechanics, because maybe we want to do the mechanics instead. So let's have a look at the mechanics.
Yeah, and the first one.
Now, it's simple harmonic motion. There's a spring which is vibrating, and we have a pendulum here. So what do we think? Is it easy or hard?
If we know the formula.
Yeah, well, what would you think it is? Easy or hard?
Hard.
No, it's actually not that easy. I mean,
Pendulum.
if I think about the students who did this last year, they kind of screwed it up a little bit.
Why?
Well, they were mixing up their formulas. For example, you have two formulas for the t. T equals 2 pi root L over G, and T equals 2 pi root M over K.
Yeah.
And they were actually mixing up the two, which one to use, you know. So, I mean, I don't think it's that hard, but the screw up risk is pretty high. Students screw this one up. So I would kind of put the mechanics down here. I would choose the electricity over the mechanics. And lastly, the fields. And this fields one actually is, not only is it hard, not only is fields hard, it's also a hard fields question. Because this is the one where they give you 4 charges, and you have to combine these together to make one electric field. Do you remember doing this one? Now, you see, that's 6 marks.
So can you do
Well, that's what I want to do next. This fields one. Okay. So, what's our final conclusion? Our final conclusion is we would do B3, B5, and B2.
Only 3?
It's 3 from section B.
so you wake up.
Now, I was angry at the students last year because some of them did B4.
Because the others look hard. The planned winners.
Yeah, well, the A part is okay, but the B part is not.
Because your table,
Yeah.
it's not that hard.
Now you see, this is going to be you. In 3 weeks' time, you are going to do this exam, you're going to look at the fields question, you're going to say, this is not too hard, you're going to do it, you're going to get 5 out of 20, and I'm going to say, I told you not to do the fields one. Because students think they can do it.
No, because I already solved it and I got it right. So
At home,
yeah.
maybe not in the exam. I can only talk about the data, okay? Here is the data. The atom question, students typically get 17 out of 20, typically. No. The fields question, students typically get 5 out of 20, typically. Okay, there are some people that will screw this up, and there are some people that will do well in this. But typically, this is what you see. Now, if you don't want to take my advice, that's fine. You know, what do I know? I've only been doing this for 10 years. What do I know? Okay, I'm just telling you, my advice as a teacher doing this for 10 years, this is how I would approach the exam. I would go in, I would do B3, I would get, 17 out of 20. B5 is the Wales. I might get something like 15 out of 20, And then the last one, B2, is the electricity. If I practice my Kirchhoff and I don't make too many mistakes in solving the simultaneous, I should also get 15 out of 20. But if I'm really good with my simultaneous equations, I could actually get 20 out of 20. And here I could get 20 out of 20.
Oh my god.
It's possible. Okay, it's not, I don't expect people to be getting 20 out of 20 in the fields. Same goes with this mechanics one, was quite hard. I expect maybe people to get 12 out of 20.
Teacher.
Yeah.
When,
But listen, don't take my advice.
when can we get our result after the exam?
I don't know.
Like
Usually.
a month?
Usually,
From later.
well, it'll take at least 2 weeks to correct the exams. Then it'll have to be sent to NCUK, where they'll have to check it, confirm that it's okay, have a meeting with us.
For what?
Well, I correct the exams first, then I send it to Manchester, then they check the exams, then they have to have a meeting with me to discuss any problems, then they say everything's okay, then we have to contact the universities, we have to say Jerry got this result, and then after the university says okay, then we give you the result. You're the last person to get the result. Yeah. First I get the result because I corrected, then Manchester gets the result, then the university gets the result, then you get the result.
What if it doesn't meet the requirement?
Then we'll send the results to your second choice.
Oh my god.
Officially, no.
Oh, okay. Can I get my result and just correct?
No, officially, I can't give you the results until like 4 weeks after the exam. Officially. But I might see you around after the exam. Okay, let's have a look at this fields question. Now, I'm doing this fields question not because I want you to do it in the exam, but because it's hard. And I want you to try it now so that you can see it's hard. Okay. Right. Well, I think the first one is actually not too bad. It's a bit of Kepler, is it? Can never remember Kepler's formula. T squared equals 4 pi squared GM
4 pi squared R cubed.
R cubed over
GM.
GM squared?
GM.
This one. 4 pi squared or cubed. The omega is the angular speed. Are you doing this one, Sean?
Yeah.
Yep. Jerry?
I'm done with it.
But it's on the screen.
Ah.
I don't want you to do part B, just part A, because I want to do part B together, so just part A.
Teacher, what is sweet? Usually one thing do not agree with our result.
What if what?
Like our grade is not enough and the grade that they want.
Who?
Sweet, you will say.
Yeah.
Like you send the first.
Send the first to the first, yeah.
And then you send no.
Then to the second.
And you send no.
Then to the third.
Send no.
Then back to China. But that, how many, oh Jerry, I was talking to Isabel about you. How many choices did you make?
3.
You made 3?
Yeah.
Okay, you paid your deposits? Should you pay your deposits?
But I decided to not pay the
So then you haven't made 3 choices.
So I only have 1 choice.
Okay, so then you made 1 choice. Okay. What grades do they need?
GCC.
B in maths?
Yeah.
C in physics?
Yeah.
Okay. C in chemistry? It's possible?
But they need EPB.
EAPB!
Whoa.
Oh, Jerry!
Bad news.
That's hard.
No.
You can do it?
Yeah.
Okay, Jerry, we believe in you.
Even though I do not believe in myself. Teacher, is that the deadline of the deposit? Is that the true deadline?
It might be okay if it's a day or 2 late. You know. When was the deadline for the deposit?
For you, it's the end of last week. And for UCC, it's last week.
Okay. I think it's not too late if you want to send it still.
Teacher, what is the formula again?
For what?
The
Kepler? Kepler's, I think, as they were saying, is t squared equals 4 pi squared or cubed over gm. First, well, Jerry, he might not have paid his deposit if he's going to a different university. What's your first choice, Sean? Huh? Did they want a deposit?
No.
Not yet. Not yet.
Why? They will.
They will, I'm sure. I'm sure they will.
Did you check the document? The email? Oh.
Poor Isabel. She's your tutor?
Oh.
Come on, check it.
You feel really good.
Any deposit.
Poor Isabel.
How much? See. What do you ask me?
Sure, I worry about my ESP.
What do you need?
B.
You too!
Yeah, anyway, G.
Oh.
But the others is BCC.
Oh.
Is the formula for G?
Oh.
Sure.
What?
I'm just asking. What is I got AAA, but I got EAP for C. Is there any opportunity or
It might still consider you.
really?
Ah, yeah.
We have
It depends on the admission officer.
Oh, it's big G.
Like you
Well, let me just put it this way. If they gave you an offer that says you need a B, and you get a B, then you've got it. If you don't get a B, it doesn't necessarily mean you definitely don't get it. It just means you're not guaranteed it. It's up to their decision. So they might say, no, we can't give it to them because somebody else did get a B. But if they have a seat extra, you know, they might consider it. You don't know. The safest thing to do would be to get the grades they ask you to get. Then you have the place guaranteed.
Is that possible that you get your grade but then get refused? You like, oh sorry, we have to refuse.
I've been doing this 10 years, and you know, that's maybe like 100 something IFY students a year. So like it's over 1,000 students. I've only seen that happen once.
Oh, it happened.
Well, yeah. This is life. Anything can happen. You know. So there's a 1 in 1,000 chance that it will happen, but there's a 9 199 in 1,000 chance that if you get the grades, you get the place.
But I mean, in general, computer science is a small field career, right? So seldom people go.
Small field? No, it's not small.
Computers are quite popular nowadays.
I mean,
Fact.
computer science.
Who knows? I don't know. I'm hungry. I'm thinking about my lunch now. Alright. How are we doing on the first part now? Monica, which part are you on? 4, okay. A couple of more minutes. Lee, there is a formula for the small g. It's in the formula book.
Yep. It's big G, it's not small G.
Which part are you doing?
G squared equals.
Oh, that one. Yeah, that's 6.67 times 10 to the minus 11.
Yep.
Ooh.
Teacher, do you know parable?
Do I know what?
The person called parable.
Porrick. Which person? How do you spell their name? Yeah, Porrick.
Patrick, the star. P-A-D-R.
Yeah, Porrick.
And that's people of our school.
Oh my
Yeah.
Porrick works there.
He talked to you.
Oh, okay.
He's the tall, angry man.
Oh, angry.
What kind?
Which one?
Really?
Oh, the young one?
No, the third guy.
The tall guy.
Why you say?
You thought he was nice.
Yeah, he came to us.
You must like the engineers then.
Teacher, yesterday he told me that I need to kindly speak to my tutor in my group tutorial.
Are we talking about the same person? This is outrageous.
Yeah, I mean, I can pay the deposit after the group tutorial.
No, what that means is you should talk to your tutor. Did you talk to Isabel?
Yeah, I know. Because yesterday night I just got my invite office. And yesterday is the deadline for my Yesterday's deadline. Yeah. So small.
How angry does this class make Isabel? Like?
But teacher, you can't blame. Because they have different systems, you know.
I make her so delightful.
Like in your class, we can wait until all the university reply, only we reply. But it's different for them.
Oh,
Are you in the UK?
No.
Are you applying to the UK?
Yeah.
So then, what's the relationship between the two of you
No,
then?
I mean, it is like, hard to make decision for them because like they receive one.
I know, but it's quite simple. It's very, very simple. Life sucks. And hard decisions will be common. Yeah, I'm sorry to tell you this because you've probably thought so far life is great and life is wonderful. Everything is great and everything is wonderful and there's no hard decisions. And sometimes, Lee,
Yeah.
you have decisions where no choice is good. They're the best. You'll love those. You'll really love those. Could I do A, which is bad, or B, which is also bad?
She would.
Yes, yeah. Yeah, but they can both still be bad options. Relax, it's only a screensaver.
Just like you will be lucky,
Right, can we have a look at this now, A part? Nearly? Sean, which part are you doing?
third one.
Third one only? Come on. I think we have physics or maths tomorrow. We have something tomorrow.
Yeah.
I'm going to use the time tomorrow to finish the lab report.
Yes.
The last section, which is the discussion.
Yes.
So,
tomorrow is Wednesday.
I know what day it is tomorrow. Do we have class tomorrow?
no.
Are you sure?
We have lecture.
So where do we have our
Huh?
Where do we have our beer?
Thursday,
I know where.
after lunch.
The location.
Ah, we'll go to Leonard's Corner. Huh?
Oh, just here.
What do you want me to do? Book a VIP room?
But you have a car. You know we can go to your hometown. No, I'm kidding.
All 9 of us in one car.
Yeah.
I'm sure I'll get pulled over.
Someone in trunk, someone on the car.
Yeah,
Someone under the car.
it's not gonna work. It's not gonna work. Why, where do you want to go?
No, I don't know. I thought you would recommend some, like good bar or something.
All bars are good bars if they serve alcohol.
Really?
Yes.
They don't serve the same beer?
I think most bars here in Ireland would serve beer. It's fairly common.
I mean, do they taste the same or?
No. Why, what do you drink?
I don't really drink.
That's okay, so you probably want something not so strong. If you don't drink, you definitely don't want to try Guinness.
Oh, but I want to try because it is famous here.
It's disgusting.
Oh, really?
It's not that bad.
You have to develop a taste for it. You will not like it.
Was it bitter?
It's just awful. It's just awful. I personally go for cider, apple flavour.
Was it the same, the can Guinness and the cup?
If possible, the can is actually worse. Yeah. What's a popular drink back in Malaysia?
I don't know. Tiger.
What the heck is that?
Honeycomb.
Is that like a sweet drink?
No,
We
it's
have
beer.
Heineken here, right?
Oh, Heineken.
Yeah.
Yes. Oh yeah, of course, yeah.
I've had Guinness, but I think
You have Guinness in Malaysia?
Yeah,
For real?
and Carlsberg.
In Carlsberg?
and we have a lot of wine.
Do you have Bulmers?
No.
Oh wait, it's called something else overseas. What's it called? The cider drink. Apple drink.
cider.
Yeah.
We have apple cider.
It's anyway, it's okay, we can get you a Coca-Cola.
No.
An orange juice.
No.
Right. Are we ready for this one now?
Yeah.
Which part are you on, Andrew?
Fine.
Good. Sean? Part 4? Oh, come on, Sean.
What's the
faster.
formula for 4?
Oh, you have to use both, like A equal to V squared over I and then W equal to V over I and then.
4.
Oh, 4. Oh, no,
Very
sorry.
equals four.
Sorry,
V
sorry,
squared.
I thought it said 5, sorry.
So
The formula in
So,
okay.
Do we come next week?
Next week? No.
Monday to
Middle,
Wednesday.
middle.
I think it's your exams next week.
So there's no class.
No class.
No class.
Tomorrow is your last class with me.
Really?
Yeah, because then we go for drinks on Thursday.
No, it's not
Yay.
tomorrow, it's Thursday.
Today's Tuesday.
Oh, I thought we go after class, no, we go directly.
No, we'll go during class time. Yeah.
Teacher, when we do the formula, T square equal 4 pi square of R cube.
I'm going to do it now anyways. Right, so the first one.
Steven,
Yes.
we have a question.
Make it good.
Even if after our graduation from BSc, are you going to answer some questions?
Remember us.
What do you mean?
No, I mean if I have any physics questions, and if I ask
charge.
Only for the students I like.
you, that's answer me.
Don't email me. Oh no, I might. Contact me on this website. No, I might. Yeah, it depends. I mean, if I can help you, I can help you.
No, I mean like very small questions.
Yeah.
like that.
Send me an email.
You
You're not going to travel down to the IFC just to ask me a question, are you?
Yeah, I will.
You will. From like Galway.
Yeah.
Right, what's the angular speed? So we have t equals 2 pi over omega.
Yeah.
So then that means omega equals 2 pi over t. So for the first one, it's 2 pi over t. Now what's the t? It's 224.7 days?
Yes.
Yeah.
Yes.
3.236.
The one read for second.
Huh?
The question one read for second.
Yeah, that's what I just did.
What? wait, what did we use for the time?
I put it into seconds.
224.7 times 12 hours times
12? 12?
Why?
Sleep.
Lip and poop. Right.
What is the poop stand for?
Poop? Yeah, thanks, Monica.
Poop? Oh, okay.
Right, what's the V? What's the V? Okay, so what
V
form?
equal
Omega
ST.
squared
V equals omega or.
Yes.
Oh, okay. Teacher, I'm using V equal ST.
Now, use this one. V equals omega or.
V squared is omega.
V square equal omega.
V squared equals omega squared or squared. It's the same as this.
R square. It's in R square. Yeah.
No, MV squared.
This omega R. A equals V square over
Yeah.
R.
That's the A.
equal R omega square. So V.
This is right, isn't it?
Yes.
Yeah, so I multiplied by the or. So the or is 1.082 times 10 to the 8 kilometers.
Yes.
1.082
See how
times 10 to the power of 8
Yes.
kilometers. Now see, Monica, there goes your 10% I said. You lose 10% straight away because you make a stupid mistake. Wait, 35.
Kilometer.
Oh yeah, because one is seconds and one is, maybe actually, hang on, let me just think about this.
Kilometer. Yes. They.
Hold on. Right, so in meters per second it's this.
But.
I know. 35018 meters per second. 35018 meters per second, which is 35 kilometers per second.
Yes.
Right. Part 3. What's the mass?
T squared.
Yeah, so we have t squared equals gm or cubed. No, sorry.
No.
4 pi squared
R
cubed over gm. Yeah, so the m is 4 pi over that.
Yes.
Right, so if we type it in now, 4 pi squared times r cubed, 1.082
Yes.
times 10 to the
11.
meters.
Yes.
Okay. And what's the time? 224 days?
Yes. To do 4.6.
0.6 or 0.1?
0.7.
0.7? How many hours in a day, Lee?
24. Yes.
1.99 10 to the 30.
Yes.
Okay, part 4. The mass of Venus is that and the radius is that. Find the time in minutes for a satellite to complete one orbit at a height of 200 kilometers. Right, okay. So, what have we got here? We have planet Venus and we have a satellite here. And the distance here is 6052 plus 200 kilometers.
Yes.
And what do we want? The t? Can I use this?
Yes.
That's it. So the t is square root 4 pi squared or cubed over gm. Ah, that's for babies. Square root 4 Did you just lose your 10%, KJ? Times, what was the radius, Sean? Oh no, I have it here, sorry. 6052,000 plus 200,000, 6.67 times 10 to the minus 11, and the mass is 4.868. 4.868 times 10 to the 24.
Yeah, 24.
So the time, this is in seconds.
Minus 6.
Divide
Divide.
60. 90.8 minutes.
91.
No, I think 90.8 minutes.
Okay.
Yeah.
Teacher,
Yeah.
what is the size of right hand machine?
I'm ignoring you now. G.
Well, that's not possible.
What's the formula for field strength? G equals GM over R squared.
Yes.
And they want it on the surface of Venus.
Yes. No.
So that's here.
Only 10.
Yeah, only this.
Huh?
Yeah.
Yeah. Oh. Ah.
There goes another 10%.
10% of 12 hours a day.
Yep, that's 10% for you.
10% is huge.
What's it? 4.868 10 to the 24, isn't it? And then the radius is 6052,000.
Where?
8.86.
Oh.
Newton. Yes, right. Newton per kilogram.
Isn't it Newton per?
It's the same, but it's normal to use Newton per kilogram.
If I use
That's fine. Really should use this though.
Thinner.
Yeah.
Teacher.
Yeah.
Okay, that answer.
What do you mean? I put in the numbers G, M, and R squared.
Okay.
their formula,
Yeah. It's in the formula book, man.
Yeah.
yeah,
Is this formula for G not in it?
no.
Are you sure?
Yeah.
F over M. You can.
G is F over M. Hang on.
Yeah, F equals G mm over I squared. So put
Now
it.
this formula book is a bit messed up, whatever way they printed it.
Put the two
Oh,
together.
sorry. GM over.
There it is right there.
Yeah.
It's right flipping there. Being able to read is an important skill for the exam, just to let you know.
What are the separate? Where's this, sir? Look at this.
Yeah.
It's not
What?
even here.
In front from
This, it's in the flipping exam. Look,
Bitch, what?
page 4
It's not in our.
in the exam paper.
Oh.
Right, Sean.
Yes.
What is electric field strength?
Oh, this one.
What is it, Sean? Or Monica, what's electric field strength? No. No. The formula, which you have forgotten, which is why I say don't do it, is F over Q.
Oh.
Yeah, so, no.
Oh.
So, the electric field strength, I'll just write E for short, is the force
Period.
experienced
Okay.
per, okay, the force felt per,
Unit.
on a, no, the force felt per unit, per unit charge in a field,
Ah.
in the field.
What is the field?
Huh? Should sound familiar because I taught it to you.
Can
Indeed.
I only give a formula?
You can give the formula if you define each letter. Can I continue? Right, so the next part is we want the electric field strength at the center of the rectangle here.
What?
Yeah, so look, we'll have to draw this, okay? You have a charge here, how big is that one? A 2C, and here a 4C, and here a 9, and here minus 3. And this distance here is a 1, and this is a 0.75. Now what I really care about is half in the distances. So, this distance from here to here is 0.5 meters, and this distance from here to here is 0.375. 372. 375. No.
It's right.
Are you sure? Okay, thank you. 0.375 meters. So that distance I know, and that distance I know, and that, and that, and that I all know. But I also want this distance here, which I can get from Pythagoras. So if you just bash into the old calculator, square root 0.5 squared plus 0.375 squared, what do we get, please? This is 0.625 meters. Yeah? Right. Are we ready for this one now? Lee? Jerry? Ready to see this? Now, this is a positive charge, so which way is the field pointed? To it or away from it? Away from it.
Away.
So this one here is for that one, okay? So I'll call this one A, just to keep track. So that's for A. B, away or to?
Away.
Away. So that one is B. Okay, C.
Where is
We know that the center charge is plus.
No, but for the definition of electric field strength, you consider the effect on a small positive charge. This is C. And lastly, for D, together with the B. Okay? So, if I want the total electric field strength, okay, that will be, well, I have to consider them all together. Now, it has two parts. It has an X part and a Y part. So we'll have an X part and a Y part for the E total. Okay, so let's see about the X part. We have the EC to the left, this part. So, and to the right we have the EA. So it's the EA minus the EC, but just be careful, I'm only looking at the X part of it. Oh, and also actually the B and the D.
Yeah.
So then plus
DA
no. Minus, because it's left. Yeah, plus or minus EB minus ED, and just remember this is X and X. Okay, if I look at the Y part, I have EC going up, minus EA, minus EB, minus ED, and these are all the Y parts. Yeah?
Sure, what do you mean X?
Wow, so big.
The X and Y, we still have to resolve it.
Okay.
Yeah, you see now it's getting quite hard. So, what is the formula for electric field strength? Well, the formula is K Q over R squared. Now the good news is, for the definition of electric field strength, it's the formula E equals F over Q per unit charge. So we imagine the Q is 1. So the Q is 1. So then the electric field strength just becomes K over R squared.
How do you assume the charge to be?
Because the definition is electric field strength is the force per unit charge. So we're imagining a 1 coulomb in the center here. I'm so hungry. Why are you doing this to me? The definition is per unit charge. Unit meaning 1 coulomb. So why would you use 2 coulombs? Except if you want to make me angry. Yeah? So just use the flippin' 1 coulomb. Okay? Right. So can we add the charge? Can we add them together now? Yep. So let's have a look now. Let's look at the x part. Okay? So we have EA. Here it is here. Now we just want the x part, so we need to know this angle. Now I don't know what that angle is. I'll just call it theta. No, I'll get it later. Okay? So I'll just say it's K over this radius. What is this? This is 0.625 squared cos theta minus EC, which is K over 0.625 squared, and then I need this angle. Is that angle the same as this angle? It is. Minus K, wait, are these all the same? Yeah, that's nice. Yeah, oh sorry, now that Q is 1, but that Q is not 1. Because remember, that's the Q caused by the source. So actually, this should be a 2 here.
But the definition is the same.
Yeah, for this one.
But they both is same E.
Yeah, but different Qs. This one is unit.
Okay.
Yes? Is that what you were asking me with the 2? Or not? No, you were saying about here, I was saying it's 1. Yeah.
I saw 2 coulomb.
Yeah, that's for this formula. Because that's for the source. Yeah. That's 2. Okay, the next one, the B. Is this one B? No, that one's C. It's 9. Okay, and this one here? What one's that? That's B, is it? That's 4. Okay, and lastly, the D. Well, I've already considered the sign. So minus 3 K over 0.625 squared. Now I have to get my angles right. Is that one has a cos theta? This is B. That's this one here, isn't it? Is that's cos theta? I think so. I think they're all thetas. I think because it's symmetric. Alright, that looks okay. 2. Now this should be negative because in total it's going to the left. 2 minus 9 is minus 7. Minus 4 is minus 11. Minus 3 is minus 14k over 0.625. And cos theta, what did we say this side was? 0.375. And this side, 0.5. And this one, So, this will be minus 14, what? Minus fraction 14, 0.625 squared, and the K is, what's the K? 1 over 4 pi epsilon 0, wasn't it? So what's the epsilon 0, please? Oh, goodness sake. 4 pi 32? Right.
No, it should be
Yeah? Minus 3.22. Oh, sorry, the cost, thank you. We still have to work out the cost, which is 0.5 over 0.625.
Teacher, why your K is down?
The K in the formula is on the top, and the 4 pi epsilon 0 is on the bottom. Is it 625? Yeah? Was it 625? Or 675?
625.
Minus 2.58 times 10 to the 11 newtons per coulomb. But then we have to do everything again in the y direction.
Teacher,
Yeah.
when we have A and B with the same angle direction, can we just cancel it become 1?
With what?
It will be easier. Like we have A pointing this way, we have C pointing this way. We can get the result, right?
You can combine them, yeah.
Which is easier, right? Or does it make it 4?
It's a little bit easier. I mean, you could reduce this down to 2 points.
Yeah,
Is that what you mean?
D and D, yeah. 2 point, then we only find the result and the angle, and the whole thing will be easier.
But that's kind of what I'm doing here as well, because I'm just.
Oh yeah.
I know, I get what you're saying. What you're doing is at the beginning combine and then resolve, whereas here I'm resolving and then combining. So like, I mean, I don't know if there's that much difference, you know. And then I have to do the same thing in the y direction. But the only difference, if I'm smart, what's the only difference? Is the only difference is it only that it's sine instead of cos? So maybe I could take a shortcut. So it'll be EC minus A minus B minus D. Okay, can you call out what's C? What number is C? 9. Minus 4 minus 2 minus 3. Whoa, 0. So all the y parts cancel. Sweet. So the final answer is left 2.58 times 10 to the 11 newtons per coulomb. So the question is, what's the direction? Left, because there's no y and it's only negative. Can someone check the answer to the marking scheme before we finish, please? That way I can enjoy my chips knowing that I got it right. And if I didn't get it right, just tell me I got it right anyways.
You got it right. What's your answer?
Yeah? Yeah? Oh, 5, not 11.
What happened?
And then power 5.
This take this.
Wait, is it 10 to the 11? 10 to the 5. Wait, don't go anywhere, KJ.
I won't.
You use
Oh, I know what it is. I forgot. They didn't print it on the exam.
Yeah.
There should be
the 10 to the power of negative.
this is a milli, or it could be a micro, but it never printed on the final exam. They use micros. Do they have a 10 to the minus 3 or 10 to the minus 6?
minus 6.
Usually
Okay, so that explains why my power is off here. If I put in the minus 6, it would take it down to 10 to the 5, which is the answer.
Whoa.
Yeah, okay, sweet. And that's why you don't do the fields question in the exam.